Hey guys, this is Mrs. Harbin, and we are starting off Unit 3 all about parallel and perpendicular lines. So grab your notes and let's jump right in and get started. You've already talked about parallel lines before in algebra when we learned that lines that have the same slope never intersect and they are parallel. We're going to do some definitions now, though, in terms of geometry. So parallel lines in geometric terms are two coplanar lines that never intersect. You can see my picture over here to the right. We have line AB and line CD. They have the same slope. Both of them have a slope of 0. They're in the same plane. I like to imagine that I could take a piece of paper or something and pass it through all 4 points, and those 4 points would be on that piece of paper. Or I could connect those 4 points with a piece of paper when I'm trying to imagine if they're coplanar. And because they have the same slope, they're going to continue on forever, completely horizontal, and they're never going to intersect. To note in a picture that lines are parallel, we are going to use the symbol of arrows. Now these arrows right here are noting that these two lines are parallel. If you don't want to draw the whole triangle, you can also just do the arrowhead part, and that also indicates that lines are parallel. Symbolically, when we write things out and we want to indicate that line segments are parallel, we're going to use two parallel lines. It looks like two L's right next to each other. And so to say that line AB is parallel to line CD, we're going to use our capital letters here to name our line. Line AB is parallel to line CD. And pardon my handwriting, I am trying to do this with a mouse, so my lines might be a little weird there. But that's how we would write out symbolically. Line AB is parallel to line CD. Now, parallel planes is going to be something that's new to you, but hopefully not too much of a jump from parallel lines. Parallel planes are planes that never intersect. I like to think of parallel planes like the floors of a building. So you've got plane K, which is maybe like the bottom floor, and plane J is the floor above that, and each of the floors of your building are going to be totally parallel, the same slope, and they're never going to intersect. We're going to use the symbolic notation that we used up above to show that things are parallel. So we're still going to use those two little lines. And unfortunately, we don't have a symbol for planes, so we do have to write out the whole word. So we're going to write plane J is parallel to plane K. And that's how we would write that symbolically. Something that might be totally new to you is this concept of skew lines. Skew lines are non-coplanar lines that never intersect. So there's no way that I could, connect these points on these lines with a piece of paper like I did up here. They're lines that are often going two different directions. Maybe one line is going up and down, north to south, and the other one might be going east to west. And they never intersect, but they also don't have the same slope because they're not in the same plane. One's going maybe front back, one's going up and down. So let's look at some examples here. In our picture, we've got maybe right here, let's start with PS. So if I'm going to use the terms front and back and up and down, we can see that PS, or line segment PS, is running front to back. And a skew line with line segment PS might be, we got some choices here, VR, okay? And VR is running up and down. It's not running front to back. So PS will continue running back and forth, and VR will run up and down. They're never going to intersect. They're not on the same plane. They don't have any points in common, so those are skew lines. Some other examples that we can see in here of skew lines, we've got TW, which is on the top of our cube here, running front to back, and a skew line with that might be UQ. Let me add my line segment notation there. UQ is running up and down. Another example of a skew line, oops, sorry about that, is PT. That's really bad handwriting on that one. And PT might be skew with QR. Let's find a PT we've got running up and down, and QR running here. Now, we can't say PT and PS. Those are not skew lines. They are on the same plane, this one right here, and they intersect at point P. So they've got to be lines that don't fall on the same plane, that don't intersect in order to be skew lines. All right, let's take a look at some examples and identify some parallel lines, planes, and segments. Now, I'm not going to write all of these out for sake of time, but I am going to say them verbally. So make sure that you are listening and writing these down in your notes. So the first thing that we want to do is name all the segments that are parallel to AE, segment AE. So let's find AE. All right, so this is running up and down, up and down. So we want to find all the line segments that are running up and down. And you're going to write those here. Again, I'm not going to write them out, but you're going to write them using capital letters and using the proper segment symbol here, notation. So parallel to AE, I see also BF running up and down. I see CG or GC, however you want to name that, and DH. Those are my 4 lines, or my 3 lines that are parallel to AE. As far as parallel planes, again, I'm thinking of floors of a building here. So I've got my bottom floor, or the bottom of the box, and my top floor. Now, these planes don't have letters on them, like the previous slide where we had J and K, and we could name our planes this way. So going all the way back to Unit 1, we're going to remember that we can name planes with 3 letters. So we might call this bottom plane, plane ABC, or plane ABD, or plane DAB. It doesn't really matter, just choose 3 of your letters there. I'm going to say ABC. So plane ABC, down here, is parallel to this top plane, plane EFG. So again, you're going to write that here. We don't have a symbol for plane. We actually have to write that out. Plane ABC and plane EFG. Some other planes that could be parallel, you've got 2 other options here. I think I'm going to do the ones on the side. So I'm going to do the side of my box. Plane BCG, I'll use those letters, is parallel to this side over here. ADH or EAD, however you want to say that. We have actually 1 third option, and if you can think of the 3rd set of parallel planes, you can stick that in your notes and we'll check it and see if you're right tomorrow. And last in this section, we want to name all the segments skew to GH. Now, I know that my colors are getting kind of hard to see here, all of that purple, and I was going to try and switch ink colors, but it doesn't look like I can, so we're going to have to stick with purple. We're going to name all of our segments skew to GH. So let me find GH. It is running east to west or side to side. And so some lines that I know that are not going to intersect it, but also don't have the same slope, are right up here in the front. This one's running up and down. It's not on the same plane. So line segment FB. Line segment EA is another one. And then I have some running front to back this way. AG is never going to cross GH. And BC is never going to cross GH. So I had 4 segments that are skew to GH. In our second example, let's go ahead and take a look at that and do the same thing. I'm actually going to have you pause the video and see if you can do number 2 on your own. We'll check the answers together in class, so make sure you have something written down there using proper notation. Go ahead and pause the video and do example number 2 now. All right, hopefully you've gotten all of your answers for example number 2. So let's carry on with some other definitions. We're going to talk about a transversal. And a transversal is just a line that intersects 2 or more lines. So in our example here, we've got line T. Remember that we can name a line either by its points, which this one doesn't have, or we can name it with the lowercase letter there. So we're going to say line T, and it intersects 2 lines. It intersects line L, and it intersects line M, and we can see the point of intersections right there. And when we have a transversal, or a line that's intersecting 2 or more lines, it creates some special kind of angles. So we're going to name and work on these angles right now. The first kind of angle that it creates are corresponding angles. Now, I'm going to be looking at this picture right here. We've numbered all of our angles. You can see 1, 2, 3, 4, and 5, 6, 7, 8. Our corresponding angles are on the same side of the transversal. Remember that this is our transversal. They're on the same side and in the same position in relation to the intersecting lines. And I'll explain what that means here. So number angle 1 is left of the transversal, and it is above or to the up and left of the point of intersection. I'll draw a little arrow like that. Well, if we go to the other intersected line right here, if we go left of the transversal and above the intersected line, so up and to the left, we see angle 5. So angle 1 and angle 5 is one example or one set of corresponding angles. If we go to the intersection and go up and to the right of our intersection, you can see angle 2 and angle 6 are corresponding angles. We then go from the point of intersection down into the left, so I've got 4 and 8 corresponding angles. And then we've got 3 and 7 as our corresponding angles. So when we talk about the same side of the transversal, that's just left or right of the transversal, and then the same position, we mean up, like above the intersection, point of intersection, or maybe going down below the point of intersection. All right, alternate interior angles. Hopefully the name gives you an indication. Alternate is alternating sides. Interior, meaning it's between the two lines that are being intersected. And they're not on the same side, non-adjacent. That's where the alternate comes in, opposite sides of the transversal. So an example of that would be, okay, in between our intersected lines, we have 4, 3, 5, and 6. Those are our interior angles. And the alternate ones are 4 and 6. So they're both interior, but they're on different sides of the transversal. And then 3 and 5. I'm going to stop writing on the picture because it's getting really messy over there. So angle 3 and angle 5. You are just going to have to look at your picture to try and find those numbers here. Let's see if I can get it erased. Okay, I was able to get that erased. So now let's talk about alternate exterior angles. So these are the angles outside of the intersected lines. So 1 and 2 and 8 and 7. And just like before, alternate is going to be on alternate sides or different sides of the transversal. So in this case, we've got 2 and 8, our alternate exterior, and 1 and 7, our alternate exterior. Our fourth type of angle that we need to know is consecutive interior angles or same side interior angles. Let's erase this here. So these are going to be on the same side in interior or on the same side in exterior. So if we go to our interior angles, 4, 3, 5, and 6, the two on the same side are 3 and 6. So we're going to write angle 3 and angle 6. And on the left-hand side, we've got 4 and 5. For alternate exterior angles, again, 1 and 2 and 8 and 7 are exterior, above and below the lines that are being intersected. I've got 2 and 7, both on the left side. So that's our consecutive exterior angles. And 1 and 8. Angle 1 and angle 8. Consecutive or same side exterior angles. Now that we've got all of our definitions, we're going to write the type of angle relationship. And if no relationship exists, we're going to write none. We're going to do these as quickly as we can, so feel free to pause if needed or come back and write these down as you go. So here are my two intersected lines, and R is my transversal. It's the one that's cutting through the two lines, so we're using that as our point of reference. So I notice that 1 is up and on the outside, and 8 is also on the outside of those two lines, but it's down here at the bottom. So it's not the same side as number 1. So that is an alternate exterior angle, and I'm just going to abbreviate that. Alternate exterior. 2 and 3, that's between the two lines, so I know that's interior. I'm going to go ahead and write that. And I see that they're on the same side. So we can write same side or we can write corresponding. I'm going to write, not corresponding, sorry, consecutive. I'm going to write consecutive interior. If you want to write same side interior, that's fine as well. All right, 5 and 7. All right, 5 and 7, they're both down and to the left. So when they're both down and they're both left, if you remember, that is our corresponding angles. They're in the same position. in relation to both the transversal and the intersected lines. All right, 2 and 7, let's find those. 2 is on the inside and 7 is on the inside between the intersected lines. So I'm going to write interior.